Good morning, Tehmina Khan is here in TKMaths is fun. This video is part 6 of videos on integration, and in this video we will study integration by substitution. So we will cover 5-6 examples and then I will give you some practice questions. So integration by substitution is applied on those type of functions. Now don't worry about what is written here a definition basically, but let me explain to you here. So if the function is given such that part of it, when you differentiate it, and that derivative is present in the function which is given here, then you can apply integration by substitution. For example, you are given cos x square into 2x dx. So if you say, let's differentiate x square, and the answer will be 2x, which is present in this integral, then you can apply integration by substitution. So let's go to the example to exactly see how does it work. Suppose this function is given to you and you have to integrate it. X is multiplied by root 1 minus x square. In integration by substitution method, most of the time what you have to substitute is given to you. For example, here it is u is equals to 1 minus x square, right? If I differentiate u with respect to x, it will be 0 minus 2x. Agreed? And then this can become du is equals to minus 2x dx. Now why I'm doing this? Actually, when you apply integration by substitution, you change all these x into the letter which you are taking as a substitution. And why we are doing this? Because we want to bring this function into simple form which we can integrate, because there is no product rule or quotient rule in the integration like it is in differentiation. So you have to change this function in a simple form, single terms, which you can integrate. So when you differentiate here, and you know what I have done here, because you know how to differentiate u with respect to x in this case. This method is this implies that du is equals to minus 2x dx. I want to replace x dx because if you rewrite it, okay, I'm rewriting this whole question here for you. So if I rewrite it, I can write here 1 minus x square times x dx. So you see I'm already getting here x dx. Only this part is extra, so let me bring it down here. So it will become, this part will become minus 1 over 2 du is equals to x dx. So I can replace this whole x dx by minus half du, and root 1 minus x square I can replace by root u. So let's see it here. So number one thing, let u is equals to 1 minus x square, and then you are differentiating u with respect to x, you got minus 2x, and then du is equals to minus 2x dx, exactly what I told you here, right? And then because we want to replace dx, and we have seen after manipulating this, if we make x dx here, leave x dx here, minus 1 upon 2 here, you will get this term. Now we can replace all easily in terms of u. See here, this part will become root u, and x dx, like I have written here together, is equals to minus half du. I hope so far it is okay. I'm repeating everything. The whole purpose of doing this is to change this function into simple terms which you can integrate. Now here it is saying let, 99% it is given to you what to take as let. Otherwise with practice you will learn how to do it. And then you differentiate whatever you are taking for substitution, you differentiate it because you want to replace dx also. And only after differentiation you can get dx. Now, so now minus half I'm taking out, and root u is actually u power half. Now when you integrate it, it will become u 3 upon 2 divided by 3 upon 2, right? U 3 upon 2 divided by 3 upon 2. And then this part will get flipped or get inverse and become 2 upon 3 plus c, because there are no limits. So now you will get this answer, and in the last, after integration, wherever you have u, you will replace it by 1 minus x square, what you have taken in the beginning as a substitution. So this is your integration of this part. Let's see another example. In this case, for example, it is given to you that u is equals to ln x. Okay. Now this looks like in the form of quotient 1 over this whole thing. We will bring it into simple form again. So when I will differentiate this with respect to x, it will become 1 upon x. And then I will cross multiply. It will become du is equals to 1 upon x dx. And if you look at this question, by the way, can I rewrite it like this? Yes or no? This question is exactly this thing. And I have to find the integral of this, right? The sign is not here, but the question I have taken are for all integration. So I have to integrate this question now. So now I know I will replace this by du. And this is already u, because this is what we have taken in the beginning, that ln x equals to u. So it will become 1 over u square. So the whole function will become 1 over u square du. And I have explained to you why. Now after that, if I take u square up, it will become u power minus 2. And simple integration, minus 2 plus 1 divided by minus 1. And whatever your u is, that you will substitute back here. Make sense? So this is how you change it. The whole problem here is what you have to take for substitution. So I'm repeating, in the exam it is given to you. If not, when you will practice few questions, you will automatically understand what to take as a substitution. Because whenever we differentiate whatever we have taken as let, after differentiation, the answer should be present here. Like I see 1 over x was present here. So with practice, you automatically get this. Now let's see this question. U is equals to sine x. I have taken different type of example to give you a broadened vision, basically. Then you will learn how to apply it in different scenarios. Now that was logarithmic function. Now this is trigonometric function. Before that we took polynomial function. They are all indefinite integral right now. There is no limit. I will take a question of limit also. So now this is given to you and you have to integrate this whole thing. So first thing I told you, whatever you are taking as let, you will differentiate it with respect to the variable here. Why? That you do to replace this basically. So let's do it. So u sine x will be equals to du upon dx is equals to cos x. Because differentiation of sine x is cos x. And then du is equals to cos x dx, right? So cos x dx, now I can replace by du. Okay, now we have to see what to do with this sine square 2x. So now we know that sine square 2x, when we see 2x, it reminds us of double angle, right? In the trigonometry, we have studied double angle and compound angle. Sine square 2x basically means sine 2x square. This is the meaning of it. Then sine 2x I can write as an identity, double angle, 2 sine x cos x, right? So I am replacing it and then squaring. 2 square is 4, sine square x, cos square x, simple squaring it. Now, so I got my sine square 2x is equals to this thing. So I will replace sine square 2x by 4 sine square x cos square x. So I've replaced here. And this was, I'm writing as it is. Now, after this, I know that sine x I can write as u. So here I can write u square. Here I can write du because we have seen here that cos x dx is equals to du. But what about this cos square x? What do I do with this? So what comes in my mind is to apply this identity. Cos square x is equals to 1 minus sine square x. So I'm writing in place of this 1 minus sine square x. Okay. After that, I'm removing the bracket. You see the integral sign is still here because I have not integrated as yet. So sine square x into 1 is sine square x. Sine square x into sine square x is sine 4x. Now it is easy for me. I know sine x is u. So this is u square and this is u power 4. And this whole is u. So I've replaced all the x's by the terms of u. Now this is very easy to integrate now. So what is the integration of u square? Is u cube over 3. And what is the integration of u power 4? u 5 over 5. Now I have integrated it. And now I can replace u again by what I took in the beginning, that u is equals to sine x. So this will help me to complete the question. So I got the integration here finally, right? Now the last example I'm taking, which is of, this example I've taken for you to solve it. I will not explain here. I will just show you the solution here directly, right? So you can put the video on pause here. Try to do it yourself, and then I'm showing you the solution here. So you will study it yourself, okay? So now you can match your working with this working, and I hope it will make sense to you. Again, if you're still doing slowly, put the video on pause and see it. Now this question I would like to explain, because now this is a definite integral, limits are here. Right. So how do we handle such type of questions? The important thing is this limit 0 to 3 is given with respect to x. When I'm substituting x plus 1 by u, it means limit will also change. So let's do it. Exactly what we have done so far. U is equals to x plus 1. So how will I, if I differentiate this, for example, it will be du upon dx is equals to 1, right? And this is 0, I'm not writing here. So du is equals to dx. So this is replaced, and this part I will write as u. But what about this x? This x need to be replaced as well. So you will make x a subject from here. So it will become u minus 1. Can you see here? So this x will be replaced by u minus 1. This x plus 1 will be replaced by u. And dx will be replaced by du. This is how we do it. So your term will become u minus 1 over root u into du. Okay. But what limits you will take? Now let's see the limits. So for limits, you will start with this. Let me write here because this looks too much here. For example, so how do you do it? You say when x is 0 and when x is 3. You know, x is 0 and x is 3. So if I plug in here, my u will be 1 because 0 plus 1 is 1. And here my u will be 4 because 3 plus 1 is 4. So my limits will be 1 to 4. Okay, so limits will be 1 to 4. So now I will integrate this function. Let's see how. So this whole question has changed into this form now. What comes in your mind? Because u over v form, quotient form, you don't apply in integration. So before showing you the solution, just giving you a hint, because if you want to put video on pause and try it yourself, you can. So this part will become this. Agreed? I am writing the reverse process of partial fraction basically. And this part will be equals to what? Now you can apply law of indices here, right? So when you will apply law of indices here, this will become u 1 minus half. Okay? And this will become u minus half. So you will get this form. Now you can easily integrate both of them because the same formula we are doing for integration. And after that, you are applying limits. And then you will get your answer 8 upon 3. You can write answer in 3 significant figure, or you can write it like this. So now I'm showing you the practice questions. I have covered almost all types. And in the past paper, last video, I will take more complicated question for explanation. So these are the practice questions. Find these integrals using the substitution given to you. So in all these questions, what substitution you will take is given to you. So you can put the video on pause and try it out yourself now. And here are the answer of those questions. Remember, answer you will check later. And there are more questions on the same integration by substitution. Try these questions as well. Again, put the video on pause, note down the questions, and then answers are on the next page. So with this, I will end the video, and in the next video, I will explain you the use of partial fraction in integration, right, which is part number 7. So thank you very much. If you have any query, you can send me the question.